Okay, today we're working on 6.03, staying in balance. So the whole idea here is that we want to make sure that our hanger diagrams and our equations are always balanced. This is a balanced hanger. This hanger is not balanced. It's kind of sideways. So when we're looking at this, you can think about something that has to be true. Which weight has to be heavier? Which weight has to weigh more than the other one? Which weights here are equal? What would happen if you take one off? So you can think about those things while you're answering these questions. If you've already done this page and you're working on this one, we're matching equations with different hanger diagrams. So here, I see on this side of the hanger diagram that there are 1, 2, 3 groups of x. So I'm going to be looking for a multiplication statement for this one. And if I look down here, this is addition. Down here, this is 3 groups of x. So I would match this with this by writing an x in this box. Then for the addition ones, I can see that this has y, and it also has 3, or plus 3 on this side. And on the other side, it's balanced with 6. So I would match this equation to something that has a space for y plus the extra 3, and it's equal to 6. To find a solution for each equation, I need to figure out how much this x balances. So if I have 3x on this side and 6 ones on this side, I need to create equal groups to show how many ones balance each x. In this case, 1x balances 2 ones, this x balances 2 ones, and this x balances 2 ones. So each x is equal to 2. In this case, I need to get y alone on one side of the hanger diagram. If I take one weight off from each side, the hanger will stay balanced. So I'm going to take 1, 2, 3 away from this side, and take 1, 2, 3 away from this side. And then I can see that y balances 3 ones. So I would say y equals 3. You can do the next two on your own. In this last part of the classwork, you need to think about how you would figure out the weight of x. What would you need to take away from both sides so that you can see how much x balances? In this one, what equal groups would you need to create? When you're writing an equation for this diagram, think about what's on this side and what's on this side. So we're going to write the things on this side. There's an x, and there's a 3. And they're equal to whatever is on this side, the 8. So we can do one example together. To find the weight of x, I could take 3 off of both sides of the hanger diagram. If I take 3 off here, I have x. If I take 3 off of here, I'm going to have 5 left. My equation would be x plus 3 equals 8. And then to find the value of x in the equation, I could take 3 away from both sides of the equation.